So again, like I said, we're essentially kind of manipulating our base hydrocarbon by adding oxygen, and we're kind of just moving it around, doing various things with it. Alcohols have our oxygen singly bonded to a hydrogen and a carbon. Ethers, we move that oxygen into the chain, singly bonded to two carbons. And the next situation we can have with oxygen is we can have oxygen doubly bonded to a carbon. So now we're going to increase the contact of the carbons with oxygen. All right? We're going to actually now take a single carbon and doubly bond it to an oxygen. So we're just kind of progressing with the way oxygen connects with the carbons in the hydrocarbon chain. When we have an oxygen doubly bonded to a carbon, we call it a carbonyl group. Notice that our oxygen is not connected to any H's directly, which means hydrogen bonding is not an option. It is a polar scenario because the oxygen will pull on the electrons from the carbon. Oxygen is very electronegative. So we've got London forces and dipole-dipole, just like the ethers. And therefore, and you're now just adding here in that ether group aldehydes. All right? Because, again, like I said, we could actually do that even at this point. We could put here, these are just our London guys. That's just London. They'll have the lowest. This is our London and dipole-dipole, dip-dip. This one here is London and H bonding. And I said there was two more. There's actually only one more that we'll be looking at to the right. There's one more group to the right, and we'll get to it later on. Yeah, there's going to be one more over here. Yeah, there's going to be one more grouping. When we get to carboxylic acids, there's dipole parts of it, there's H bonding parts of it, and there's London force parts of it. In other words, there's all three of them existing in the same molecule. Makes it really sticky. Okay, so that's just adding aldehydes to our list. Aldehydes are easy to name because they're like related to alcohols. We don't need anything fancy like we had with the ethers, like some methoxy or something crazy like that. So the carbonyl group has to be in the chain, and actually, because it's on the end, it always starts the chain. And instead of all, we give it al is the ending. So instead of pentanol, you could have pentanal. All right? Now, in an aldehyde, the carbonyl group is always number one because it's always at the end of the chain. And so we don't need a number to tell us where the aldehyde group is. Remember, the alcohols could be anywhere on the chain. We could put that OH anywhere. We could have a 2-pentanol or a 3-pentanol or a 1-pentanol. But for aldehydes, it's always one. No need to number the location of it. 2, 3, 4, doesn't matter which way we go, 5. So the base name here is pentanal. It's pentanal. Okay? I do have a group. It's in the number 4 position. It could be in the 3 or the 2 position, so I do need a number. So this is a 4-methyl. Oops, what am I doing, methyl? I'm losing my mind. 4-methyl. Here we go. Let's get rid of that. 4-methyl pentanal. All right? So again, aldehydes are easy. There's that guy there. That's number 1, no matter what. Number 2, number 3, number 4. Here we're being mean again. Look at here. I could have 5 or 6, or I could have, there's a C3, right? I could have 5, 6, 7. That's the longest there. There's us trying to just be mean. Our textbook likes to try to be mean. I don't think it means to be mean, but it does like to put those groups on the end. It just likes to be mean. So what do we have here? What is this main chain called? Hept for 7. Heptanal. 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 And I got a branch off of the 2, and I got a branch off of the 4, and I got another branch off of the 4. So now we need some alphabetical. What's going to come first in that branch? C does come before E. I was going to put the ethyl first, but C does come before E. 4-chloro. 4-chloro. 4-ethyl. 2. All right, now I'm in trouble. Methyl. And then that connects over to here, obviously, right? That's how that works. Just like that. That's beautiful. Maybe not. 4-chloro, 4-ethyl, 2-methyl, heptanal. That's just fun. It's just fun words, like silly speak. Okay, let's. I'm not even going to move down here. 3-methyl pentanal. Oh, look at, I have pentanal up here, and I've got 4-methyl pentanal, and I'm telling you to draw 3-methyl pentanal. Isn't that a little silly? It's really the same thing, except I'm moving that thing over to the number 3 position. Silliness. 1, 2, 3, 4, 5. Now, as soon as you see the al ending, you're putting double bond O, right? That's what you're doing. That's the carbonyl group. As soon as you've got the al ending, double bond O right at the front, okay? Then you're going to go 1, 2, 3, put your CH3, and then again load with H's, right? Because it's on the end, you can put the H on the outside here. That's typically the way it is. If you were to put the H on the inside, like the way we fill in our H's, I'd say correct. Not a big deal. It doesn't matter where the H goes there. H2, H, H2, H3. Okay? So the al tells you the double bond C is on the end. So that's an aldehyde. We've just increased the connection of that hydrocarbon with the oxygen. Now, you might think that we might talk next about reactions of aldehydes. But in this case, we go straight into ketones, and that's because aldehydes and ketones are prepared the same way. We prepare them with the same reaction. It depends on the type of alcohol we use to prepare them. That's what determines whether we get an aldehyde or a ketone. All right? So we're going to roll into ketones here. We'll talk about how to name them. And then we'll talk about how we prepare both aldehydes and ketones together because they're prepared from the same stuff. They're just little differences that we need to be aware of in order to determine it. So a carbonyl group. Our ketone has a carbonyl group, non-terminal. When we say terminal, we mean the end of the chain, right? So if we have a terminal alcohol, it's at the very end of the chain. If we have a terminal carbonyl group, it's at the very end of the chain, and it is an aldehyde. If we have a non-terminal carbonyl group, we say that it's in the chain, all right, in the middle of the chain. I don't know if anybody wants to add that. I'll add that right there. Non-terminal means in the middle of the chain, of the carbon chain, which means it's flanked by 2 carbons. It's also polar, and again, it does not have a hydrogen bonded directly to the oxygen, and therefore, it's still just dipole-dipole. So its forces are very similar to the aldehydes. Their melting points and boiling points are actually very similar. And I'm pretty sure our next slide is going to put then the ketones on our good old summary sheet in the same grouping as the aldehydes and what else was in there? Ethers, I believe, right? So again, so now we've got aldehydes, ethers, and ketones in the same grouping. So if we had comparable ones, meaning they've got the same number of carbons approximately, then they'll have very similar melting points and boiling points. All right. So now we've got our ketones and aldehydes in the same grouping here. Okay, I think we've got that. Naming ketones. Well, I'll switch to the other one, but you're looking at your page, but I'll look at this here. That's where my eyes go to. It ends in "-one", right? So an aldehyde ends in "al", which is at the front, which is kind of weird. But the ketones end in "-one". Okay? They end in "-one". Again, the parent chain has to contain the carbonyl group. So you look for where that double bond is. Now, in this case, that double bond can be in different positions in the chain. So we do need a number this time. For aldehydes, no number needed, always in the number 1 position. For ketones, we do need. Okay, so let's take a look at this one. So again, we are locating longest chain. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, not long enough. Has to have the double bond. 1, 2, 3, 4, 5. So what's our base name for this before we put any branches? Yep. Yeah, very good. It's a 2-pentanone. 2-pentanone. And now I've got a branch, obviously. That branch could be in different positions, so I need a number. What's our branch? It's a 3-methyl. 3-methyl 2-pentanone. Okay? All right. So let us continue. And what do I want to do? I want to clear the writing. Can I clear? Nobody's said no. We will head to the right. Look at all the windows I got open. That's exciting. All right. Again, we're being a little mean. Look at this C2H5 here. As soon as you see something that isn't just a methyl group and you're getting close to the end of the chain, right? That's when your brain goes, uh-oh, they're trying to mess with us here. What's our chain here? What's the longest one? What do you got there, Albert? So we got 1. Oops, I need my pen back. Okay, get rid of there. So you're saying then 1, 2, 3, right? 4, 5, and then I got a 6, 7 here. Yeah. So what is this? What's the number goes with it? I'll take the entire thing. Give it to me. 3, 4, 5. Oops, extra comma. I got to get rid of that. Tri-methyl. Oh, it is a 2. That's okay. 2, 4, 5. Trimethyl dash 3 dash heptanone. And I've got some mistakes in there that I'll clean up here. That comma doesn't need to be there. That is a 2. Excellent. 2, 4, 5. My chain heads up that way. Nice job. Okay? Let's draw one of these. Here we go. Heptanone. 1, 2, 3, 4, 5. Do you count? Are you laughing that I count it all out? Oh, because I do. I have to count it out. 1, 2, 3, 4, 5, 6, 7. When I get beyond 5, you know it's getting dicey here. So we got a 2-heptanone, double bond O. So that locates my carbonyl group. I got a 3-bromo, Br, a 5-methyl, 4, 5, CH3. And now I'm loading with H's, right? H3, full, right? No H's on that guy. H, H2, H, H2, H3. Did I get it right? Yeah. Excellent. You guys, here, I'll do what some of you guys do. I'll give myself a big check. Way to go. All right. Aldehydes and ketones are structural isomers, which means, right, they have the exact same carbons, hydrogens, oxygens. Again, it's just the difference in the position of the double bond. And I think my next slide then is on preparation, and I'm not going to go into the reactions because it does take a while to do a proper explanation of this.